Hi, I'm Corentin Thierry, Sales Manager at BARTEC US for Process Analyzer Technology PAT Group. Today in this video, we will be discussing the rapiDist 4 measurement unit. The rapiDist 4 comes out of the BARTEC Benki factory in Germany and is part of one of the two distillation analyzer that BARTEC Benki and the BARTEC Group manufactures. In a few minutes, I will quickly go over the differences between both analyzers before diving deeper into the rapiDist 4 measurement unit. In this video, we will cover three sections. The first one will be the various components that are in the measurement unit. Then we will look into what is a typical flow path for the sample as it goes through the measurement unit. And then finally, we will look at some of the basic and standard maintenance and preventive maintenance for the measurement unit of the rapiDist 4. All right. So what is the difference between a rapiDist 4 and a DPA4? Well, basically, they're both built with the ASTM D86 philosophy in mind. The big difference is one is correlative, the rapiDist 4, the other one, the DPA4, the distillation process analyzer, is compliant to the ASTM D86. And this has mostly to do with the sample size and therefore the speed of the measurement. The DPA4 uses a 100 milliliter sample and therefore can take up to 1 hour to do the full distillation curve. Whereas the rapiDist 4, depending on the sample, uses 10 to 20 milliliters of sample and can therefore achieve a full distillation curve from IBP, initial boiling point, to FBP, final boiling point, in 10 to 15 minutes for gasoline and diesel, and I would say up to 20 minutes in some very unique situations. So with this difference clarified out, let me dive into this measurement unit, which is a subsection, a part of the entire analyzer. It's really a show unit, as we call it, and that is going to give us a good idea of what is the measurement section of the rapiDist 4 composed of and how it's working. So here we have the evaporator. The evaporator has two inlets, nitrogen and sample, and two outlets, the drain, and at the top we have the gas phase outlet connected or with a temperature sensor right on top of the outlet. Here at the bottom, we can see a cartridge heater, which is used to heat up the sample. The next component we're going to look at is the condenser. The condenser has an inlet for water and an outlet for, again, water. The water coils around the sample, thus cooling it and changing it from a gas phase to a liquid phase once it passes through. Inside this big aluminum block, we have an IBP, initial boiling point detector. This IBP detector will monitor the first drop of liquid that comes out during the distillation, thus giving a very accurate and precise measurement of the initial boiling point. As the sample is distilled, it then falls into a relatively large glass capillary that we call the receiving unit. The receiving or receiver unit is continuously monitored by a camera, thus allowing a tracking or monitoring of how much sample has been recovered and or evaporated depending on how the internal calculations in the analyzers are set up. In parallel of the receiver unit, the receiving unit, we have a dosing unit. The dosing unit is another glass capillary that is used, as the name suggests, to dose the sample in preparation for the next analysis that is going to happen. Both the receiving unit and the dosing unit are monitored by the camera simultaneously and continuously. With the various components now presented, let's get into a typical flow path. So first, the sample is sent from the dosing unit all the way into the evaporator. Once it arrives in the evaporator, the cartridge heater is turned on. The heat settings and the heating settings, I should say, are adjustable in the software, thus allowing for more sophisticated heating actions or heating cycles to get the sample to evaporate. As the sample evaporates, the vapors reach here the temperature probe, thus reading instantaneously the temperature of the gas before it goes into the condenser. The sample that gets into the condenser, and as the name suggests, goes from from gas phase to liquid phase by using the coolant, which is usually, as I mentioned, water. Water that can be provided, by the way, by a BARTEC Benki chiller that we also provide most of the time with our distillation analyzers. As the liquid exits the condenser, the IBP detector will look for the first drop of liquid, giving a very accurate measurement of the initial boiling point. As the cycle continues to happen, the receiving flask fills up and is continuously monitored by the camera. We therefore have a very good measurement of what is the amount of sample that is being recovered, and depending on how the calculation is made afterwards, we can deduce the evaporated content as well. Once all of this is done, the sample remaining is purged out using nitrogen, and we can start the cleaning process before we load the next sample for the next analysis. With all this said, this is a typical flow path of the sample as it goes through the measurement cell. Regarding maintenance, the maintenance for this system is relatively small, or relatively low, I should say. For the most part, it is focused around the evaporator. There are two components, the evaporator itself and the cartridge heater. The cartridge heater is not known to fail at a certain frequency, but we do see them fail once in a while, in which case they need to be replaced. Regarding the evaporator itself, as with all distillation analyzers, evaporators or flasks tend to get a deposit or a buildup of coke and or other materials that is a natural process of the distillation process. So in the rapiDist 4, we have a built-in auto decoking function that allows to extend the life of the evaporator. What this does is it turns on the barrel heater to a very high heat setting, thus removing as much of the deposit as possible. With this being said, this is not a fix-all solution, so at some point the evaporator needs to be replaced so that we can start with a new fresh surface. Now, the entire analyzer has other maintenance needs, but as far as the measurement cell is concerned, this is the only two components that will require, I wouldn't say regular, but that will require at some point some maintenance. Now, this covers the review of the measurement unit of the rapiDist 4. If you have any questions, if you're interested, or if you need to know more, please feel free to reach out to us and we can go more in details as to how this works, what are the components, or I should say how the components are made, and we'll be more than happy to answer your questions and help you get one of the rapiDist 4 distillation analyzers into your plant. Thanks and have a nice day.